Welcome to Graphing Linear Inequalities. So for some notes here, we have solutions to linear inequalities. Solutions are coordinates that when you're looking at a graph are when on a graph are on a solid line or are in the shaded area of the graph. When it comes to an ordered pair from the inequality, we substitute them in the coordinate x and y. So we're going to see if 2, 5 is a solution to 2x minus 3y is less than 15. So we're going to take where the x is and we're going to replace it with 2. Where the y is, we're going to replace it with 5. And simplify the left side of the inequality. 2 times 2, so order of operations. We have multiplication here, and negative 3 times 5 is negative 15, so 4 minus 15. 4 minus 15 is negative 11. Is negative 11 less than, remember that's a less than, 15? Yes, it is. So the ordered pair 2, 5 is a solution to the inequality. All right, let's try with negative 1, 7. So I have my x and y. I'm going to replace again with the x and y in the inequality. So 2 times negative 1 minus 3 times negative 7 is less than 15. To your order of operations, we have parentheses, but inside the parentheses is already simplified. Then we don't have exponents, so let's do multiplication, left to right. So negative 2 plus 21. Make sure you know that that's plus 21. Negative 3 times negative 7 is positive 21, so plus 21. 19 is less than 15. No, it is not. So negative 1, negative 7 is not a solution. 3, negative 4. Let's try that one. X, Y. So we have 2 times 3 minus 3 times negative 4 is less than 15. We have 6 plus 12 is less than 15. 18 is less than 15. No, it is not. So 3, negative 4 is not a solution. What about 0, 0? So we have x and y. They're numbers, so we just substitute them in, just like the others. So don't try to do this in your head. 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than 15? Yes, it is. So 0, 0 is a solution to the inequality. All right, moving on. So how to graph linear inequalities. We're going to put the linear inequality when we're graphing into slope-intercept form. So this is y equals mx plus b. So we have to solve for y. Be sure to flip the inequality when you're multiplying or dividing by a negative number. That's important, very important. Otherwise, things are going to be graphed wrong. All right, when we're graphing a line, we're going to graph using a solid line for greater than, or it's actually the equal to is the key here, equal to. That's a solid line. That's what you've always graphed is solid lines for equal to is when you have an equation. So when it's equal to, it's a solid line, so less than or equal to. And then it's actually, we're going to have a dashed or dotted line for when it's not equal to. Doesn't matter, greater than or less than. Shading. Now we're going to shade the graph. We're going to shade the graph above the line. So this would be for greater than or equal to. And above the line would look something like, if a graph is this way is above. If a graph is like this way is above. That's above the line. Shading below the line for less than or equal to. And below would look something like this. So if you have a line there, shade below. If you have the line like this, and it can be dashed or solid, but below the line. All right, let's graph some. So example 1, first we need to, number 1, put it in slope-intercept form. So we need to solve for y. So first we need to subtract 2x. Remember, I want to get this into y equals, well, it's an inequality, so it's not really equals, but mx plus b. We want the x term first. So here's our x term that we're moving to the other side of the inequality. We did not multiply or divide by a negative, so the inequality stays the same. And I'm going to write negative 2x and a plus 15. And now to break up a term, we have multiplication, so we divide. We get y, oh, we divided by a negative. Be very careful with that. We're dividing by a negative. So when you divide by a negative or multiply by a negative, you have to switch the inequality. So switch this. Inequality from less than to greater than. A negative divided by a negative is a positive 2/3. That's your slope. 15 divided by negative 3 is a negative 5. So now when we're graphing this, we have our y-intercept of negative 5. So that's our y-intercept. So we're going to go down 1, 2, 3, 4, 5 on our y-axis. And we're going to use our slope. The slope is 2/3. That's our slope. So we're going to go up 2 because it's positive and right 3 because 3 is positive. So from the y-intercept, I'm going to go up 2, right 3. Up 2, right 3. I can't go down 2 and left 3. It's off the graph. It doesn't really look that great. So we're going to now look at number 2, solid versus dashed. We have a greater than, not equal to, so we're going to dash in the line. So dash line, dash line, dash line, dash line, dash line, dash line. All right, now we're going to go, are we shading above or below? Well, it is greater than, so greater than means shade above. So we're going to go, what is above? If you see, my shading is above the line. That is greater than. It means any coordinate inside of the shaded area is a solution. On the line is not, because it's a dashed line. It is not equal to. All right, I'm going to do a couple more problems here. I will choose number, let's see here. I'm going to do number 5 for you, and we'll do the rest in class. So number 5, I need to first get y by itself. So it's a positive x, so I'm going to subtract x. Negative 4y less than a negative x. 8's positive, so plus 8. I'm going to then divide by negative 4. When you multiply or divide, don't forget to change the inequality. And we have a negative divided by negative is a positive. 8 divided by negative 4 is negative 2. Now I need to figure out my slope, so it's going to be a 1x. So 1 times x, so I'm going to pull that slope out, 1/4 minus 2. So our y-intercept's at negative 2. Our slope is up 1, right 4. And then our slope is down 1, left 4. We could do that also. Again, it's a dashed line here. And where do we shade? Greater than. Greater than is above. So anywhere in the shaded area is going to be a solution. Now let's take a look at number 8. We'll do a number 8. Number 9, y equals negative 4. Y equals, we're going to go on the y-axis to negative 4. That is your y-intercept. And y equals is a horizontal line. Anywhere along the horizontal line, any one of these points, it's when, so this first point is negative 1, negative 4. Next point is negative 2, negative 4. Negative 3, negative 4. You might be like, why are you doing this, Mr. Johnson? Well, here, this is your reason. The y is always negative 4 here. And that's what this equation is. Y is always negative 4. So that tells you it's a horizontal line. It's equal to, so it's going to be a solid line. And now shading, it is less than. That's a less than sign, so we're going to shade below. All right, let's take a look at number 9. Number 9, we have 3x is 3, so on the x-axis we're going to go over to 3, and you can always look at like 3, 1, 3, 2, 3, 3. The x value is always 3. Now it is not equal to, so we're going to have a dashed line. And then let's look at, it's a greater than. Greater than means we have to shade towards the, well, it's usually above. But in this case, above is not, there is no above. So we look at which numbers are bigger than 3. Well, here's 4, 5, 6. So we're going to shade to the right.